Hello friends, welcome to this video. In this video, I'll be giving you the trick to find out the characteristic polynomial for any 2 cross 2 matrix or 3 cross 3 matrix. Okay, so we'll be proving that trick for 2 cross 2 matrix. I'll give you hint for 3 cross 3 matrix and you guys will prove. Okay, really simple thing. This is really important because during an exam you want to save your time. Correct. So if you are given a matrix, if you can directly write out the characteristic polynomial, that will save lots of your time, right? Okay, so let me just consider the general case. Let my A be any 2 cross 2 matrix, this. Okay, so my A is A, B, C, D is any 2 cross 2 matrix, and I am interested in finding out the characteristic polynomial of A with the variable lambda. We know that this characteristic polynomial of A with lambda is actually nothing but my determinant of A minus lambda I. You can consider lambda I minus A, but in that case you have to be much more precise because you have to think a lot, because you have to change sign of all of them and you have to do accordingly. So in that case, lambda I minus A, there are chances of making an error is more. So I prefer this. So what is this same as? This will be I2, correct? Because we are considering 2 cross 2 matrix. So this is same as what? This is same as A, B, C, D minus lambda I2 means it is lambda 0, 0, lambda. That is same as what? That is determinant of what? That is determinant of A minus lambda, B, C, D minus lambda, right? It's so simple. Okay. After that, the determinant of this is same as what? This is same as product of this two, that is A minus lambda times D minus lambda minus BC. Let me just expand this. So this is nothing but AD, correct? AD. Then this time this, and this time this. So it is minus lambda times A plus D, correct? Simple. Plus lambda square minus BC. So that is same as what? That is same as lambda square minus A plus D times lambda plus AD minus BC is the constant term. Okay, so if you observe this, this is really special. If you see, my coefficient of lambda square is 1 always. My coefficient of lambda is nothing but minus AD. That is A plus C, sorry, minus A plus D. So what is A plus D? That is nothing but trace of this matrix, correct? So what I'm getting is, this is same as lambda square minus trace of A times lambda, right? Trace is what? Trace is nothing but sum of the diagonal entries. This is nothing but the diagonal. This is not considered to be diagonal. This is nothing but our main diagonal, right? Whenever just I'm using the word diagonal, that means we are considering this. Okay, main diagonal is this. Okay? So trace is nothing but sum of the sum of the diagonal entries. So it is A plus D, correct? So A plus D. So the coefficient of lambda is trace of A. Okay, the last one, this is literally simple, AD minus BC. AD minus BC is nothing but determinant of A. So it is plus determinant of A. So I found this formula. So note this down. This is nothing but the formula to find out the characteristic polynomial for 2 cross 2 matrix. So what you need to find out? You need to find out the trace, okay, and you need to find out the determinant of the matrix, and you can write the characteristic polynomial for 2 cross 2 matrix directly. Okay, just note it down once. We'll see one example based on it. Okay, so the example is this. So I want to write the characteristic polynomial. Let me just try to write directly. P A lambda is nothing but, I know the first term is lambda square, then it is minus trace times lambda plus there is determinant over here. Okay, what is the trace in this? My trace of A is nothing but sum of the diagonal value, that is 4 plus 2, that is 6. So I will write 6 over here. What is the determinant of this matrix? My determinant of A is what? My determinant of A is 4 2s are 8 minus 6 1s are 6. 8 minus 6, that is 2. So this is nothing but the characteristic polynomial for this matrix. It's so simple, correct? So that trick helps us a lot. So now I think this example is okay. You try to create few more different examples. Otherwise also, after completing a few more lectures, I'll give you lots of homework questions. So don't worry about exercise and practicing. We'll do those things. But for now, let us just discuss for 3 cross 3 matrices. Okay, so let me consider A, B, any 3 cross 3 matrix. So let me just write A, B, C, D, E, F, G, H. I don't want to use K, I and J, so I'm using K. Okay, so this is nothing but the matrix A, which is 3 cross 3. What will be the task? And my task is to find out TA of lambda for this. Correct? So you know how to find out. It is same as determinant of A minus lambda I3. That is same as what? That is same as determinant of A minus lambda B C D E minus lambda F G H K minus lambda. Right? Now what you guys will do, you will just find out the determinant of this. I will just let you know the final answer and you just verify is it coming or not. Okay, so the final answer will be, I know I am just skipping few steps because I feel determinant can be found. It will take too long for me to write and explain, but it is really trivial thing, right? So the final answer will be what? Since it is 3 cross 3 matrix, the leading power will be 3, right? The degree of the polynomial will be 3, that is lambda cube will be the first term. Then there will be a minus sign. Then there will be trace of A times lambda square. There is an alternative sign. It is plus, minus. Then there will be plus. Over here, there is some coefficient of lambda. Right? There will be some coefficient. And at the end, there will be minus of determinant of A. Once you simplify this, you will be able to find out this thing will come automatically. Let's see what comes over here. Over here, you will find out it is same as A11 plus A22 plus A33. Over here on this bracket, you will find out this thing. What are this? These are nothing but minus. We call it to be minus, right? Diagonal minus, I say. What is A11? A11 is nothing but A11 minus is what? We delete this and this, that is first row and first column, and find out determinant of this. What is A22? A22 is nothing but deleting second row and second column and find out determinant of this things, right? What is A33? That is nothing but deleting third row and third column and find out determinant of this. Okay. So this is nothing but the formula. On the next page, I'll write the formula once in detail. Let's see. So for 3 cross 3 matrix, for 3 cross 3 matrix A, the formula is what? The formula is PA of lambda is same as, it is lambda cube minus trace of A times lambda square, then it is plus A11 plus A22 plus A33 times lambda, and at the end plus, then the minus sign, minus determinant of A is the last term. Okay, so let us just find out those things for this polynomial. Let me just keep it a simple one. So my polynomial is, suppose it is some upper triangular matrix. It is minus 1 2 3, so it is 1 0 5 0 0 0, right? So my A is equal to this. I want to find out the characteristic polynomial for this. So let's see what the characteristic polynomial will be. Characteristic polynomial for this is same as lambda cube minus trace. What is trace of this? Trace is nothing but sum of the main diagonal entries. It is 3 plus 2 5, 5 minus 1, so it is 4 lambda square. The minus sign was already there. Plus A11 plus A22 plus A33. What is A11? A11 is nothing but determinant of 2503, right? Deleting first and first, so it is same as 6. What is A22? Make sure it is A22 means you will delete second and second row and second column. Don't go for some other one, right? So A22 means second and second, so it becomes minus 1 0 0 3, so that is same as minus 3. What is A33? A33 is nothing but deleting this way, so it is minus 1 1 0 2, so it is same as minus 2. If I add 3 of them, I get answer as 1. Correct? So it is 1 times lambda minus determinant of this. Okay, one note, if you guys don't remember, if you don't know the fact, I will give you the fact. In a triangular matrix, the determinant is nothing but the product of the eigenvalues. If you are going to find out the eigenvalue, I'm just continuously repeating the word eigenvalue, which will be there in the unit 2. So let me repeat the statement again. The determinant of a triangular, upper triangular, lower triangular matrix is nothing but the product of the diagonal entries. Means if you're going to find out the determinant of this, that is nothing but the product of diagonal. Means 3 into 2 into minus 1, that is same as minus 6. Correct? So you can make this plus. This is nothing but your characteristic polynomial for this matrix. It's really simple. It will save lots of your time. But for now, I think it's enough. For any doubt, any query, write in the comment box. Guys, please subscribe to the channel. Support me. You can find me on Insta. I will give the link in the description box. For any doubt, difficulty, you can contact me over there. For any of your requests, I am always there. Okay. Thank you so much, guys, for watching this video. I hope you liked it. Please share it with your friend and like this video. Okay. Bye bye.